This video is for the review for pre-calculus. We're going to try to do this in one video, but if it's too long, we'll go ahead and break it up into two, okay? All right, so this very first problem, you guys have it as number 1. It's on the first page. They're asking you to construct the inverse of the graph and then compare the domain and range for the original, so f of x, and the inverse, which is f negative 1 of x. So let's go ahead and start with the domain for the one that's already here. So this right here, this is f of x. The domain starts on the left side. So on the left side, we have this point right here. And that point looks like it's 0, -2. So I'm going to label that 0, -2. And we're looking at the x value. So the x value would be 0. Okay. This point over here, well, it doesn't exactly stop. It goes on forever. So this arrow goes on forever. And I know that if it's going forever, it's going forever. Well, down, it's also going forever to the right. So that's going to be all the way to infinity, okay? Now 0 is a solid point, so this point right here is defined, and infinity is unreachable, so we put a parentheses for that. For the range, we're going to go ahead and look at the y values now. So we're looking at from the bottom all the way to the top. So when you do range, you always read the bottom first. In our case, this is going forever down, which would be negative infinity. Okay, so the range starts from negative infinity and it goes all the way up to this point, which happens to be -2. Okay, and again, infinities have parentheses. This -2 would be defined, therefore it is with a bracket. Okay, so that's easy enough. Now, let's go ahead and think about the inverse for a second here. So inverse, if you guys remember, means that we are switching. So we're going to switch the x and y values. Now, I do have one point here. I'm going to go ahead and label one more just for the sake of, having more than one point to plot. Let's go ahead and do this one right here. So this point right here looks like it's 2, -6. Okay. So for the inverse, which we're going to denote with this little f to the -1 power of x, we have to switch all the numbers. So instead of 0, -2, we would have -2, 0. Okay. Instead of 2, -6, we would have -6, 2. Okay. So that's our first step. And then we're going to go ahead and try to graph this and see what's going on with that. So the first one's easy enough. It's -2, 0. So -2, 0. So that one's right here on the x-axis. Okay. The next one, -6, 2. Notice that it's gonna go off the graph a bit. So it's gonna be somewhere, I don't know, over here. -6. I'm gonna say it's like right there somewhere. So this graph, and let me actually, oh, that's not what I meant to do. This graph is going to look something like that. Okay, where it's kind of going in the other direction, completely opposite of this one. But that kind of makes sense because if you remember, this type of behavior for inverses is usually a reflection over this line. Okay, so our graph should kind of reflect over and go the opposite way. Okay, so we're going to go ahead and find the domain for this one now. So the domain for this new graph, so this would be f of inverse. Okay, this is f of inverse of x. Is going to start from the left side. So on the left side, the arrow is going forever. Okay, which would be negative infinity. Okay, parentheses. And it comes all the way to this point, which happens to be -2. Okay, now let's look at the range. So for the range, we start from the bottom and then we go up. So the bottommost point for this purple graph is this point again. And the y value here, so let me write this out. The y value here is 0. So it's going to be 0 all the way to, well, it goes up forever. So all the way to infinity. Okay, like so. Now, if you notice something, there is an observation that you should be seeing here. The domain for the inverse happens to be the exact same thing as the range for the original. So you see how these two are the same, okay? And the range for the inverse happens to be the same as the domain for the inverse. So again, these two are the same. So that makes complete sense because if you think about it, the inverse is just switching x and y. And remember that x represents domain and y represents range. So if it works for x and y, why not for domain and range? So what I can write here for my observation for range is that the range of f of inverse equals the domain of f of x. And again, the reason this works is because all we have to do is switch x and y. So this is our key thing right here. Okay. All right, that's it for that problem. That's how you do the other ones as well. So if you have questions during class, you can go ahead and ask me on Monday. Let's move on to another one. So this one is number 4 in your, again, on the very first page. It says that it's the year 3044 and the zombie apocalypse has finally happened. The human race is depreciating, so depreciating at a rate of 75% each year, modeled by the function f of x is equal to all this. I'm not going to even try to read that. It's that huge number, okay? Describe what the end behavior looks like over an extended period of time. Okay, so on your paper, you don't have the graph for this, but you will have access to graphing calculators. So one thing that you can do is, well, you can graph it, okay? You can graph, okay? I went ahead and used Desmos graphing calculator for this one. You want to write that down, you can. It's a pretty neat app you can get on your phone, okay? So I use Desmos to graph this one, and this is actually what this graph looks like. If you zoom out more and more, you'll see that this line goes up forever, and this one gets closer and closer and closer to 0, but it never actually crosses over 0, okay? So just keep that in mind. So if you kind of want to see like another visual, it kind of does this, okay? So anyway, we're looking at the end behavior over an extended period of time. So we should know that end behavior is as x approaches negative infinity, blah, blah, blah. As x approaches positive infinity, blah, blah, blah. But this one is asking for a specific time. It's an extended period of time. So you have to think about time and how it can only be positive. So here, time is positive. So that means we're only going to look at the right side. We don't care about the negative side because, well, that would be going like backwards in time, which in this era is not possible. Okay, so we're going to say just look at the right side. So right side only. Okay, so as we go to the right, so as we're going this way, okay, so as x approaches positive infinity, okay, what is f of x doing? Okay, well, I told you that this curve, so this red curve, is getting closer and closer to 0, but it's not actually crossing it. So we can't say that it's going to negative infinity because negative infinity would mean it's going down, which it's not. So therefore, it's getting closer and closer to 0. So that would be our answer. It's just going to 0. Okay? And that's it. That would be your answer. Okay? Again, any questions, just let me know. You can also email me as well in case this isn't during class or I'm not there, okay? Next one, describe the end behavior for the polynomials. So we're looking at this one now. Now this one, you can graph it if you so choose to. So this one, we can graph it if you wanted to. However, you should know by now, given some of the notes that we've been doing, how to do end behavior given the degree and given a, okay? So right here, the degree is 5. So it is odd, first of all, okay? And a Remember, this right here is A, okay? A is equal to 2, positive 2 at that. A is positive. So let me erase that, it's kind of messy. But A is positive, so degree is odd, and A is positive. So according to our little chart, which is in your notes, remember you will get to use your notes for the test. According to our little chart, this graph should look something like that, where the ends just kind of go opposite of each other. Okay, that's it. All I had to do is look at my leading term, and that should give me the end behavior. Remember, the end behavior of the leading term is the same as the end behavior of the polynomial. Again, that's also in your notes. So for the left side, let's go ahead and color code this. So for the left side, we have that as x approaches negative infinity, so over here, okay, f of x is going to negative infinity. And on the right side, so the right side, we have this right here, as x approaches positive infinity, well, f of x is also going up. So positive infinity. In case you can't see that, let me rewrite that. Positive infinity, okay? And that's it. Next one. So this one we did I'm going to do all together because it's kind of, these three are related to number 12, okay? I believe this is on the back of the first page that you have. So we're just doing more end behavior. So let's go ahead and do that really quickly for all three. I'll go ahead and use the same colors that are here. So on the left side, so that's going to be x approaches, x approaches negative infinity. Okay, so on the left side, f of x is going to, well, it's going down. Okay, so it's also negative infinity. Okay, on the right side, so over here, so x approaches positive infinity. Okay, f of x is going, well, it's going up, so positive infinity. Okay, that's it for that one. For the middle, on the left side, so now we're looking over here, it's going up, so as x approaches negative infinity, make it a little smaller, as x is going to the left side, so negative infinity, y is going up. So f of x is going to positive infinity. Okay, and on the right side, so as x is approaching positive infinity, well, the graph is going down. So f of x is going to negative infinity. So far these two are opposite. You can even tell by looking at the graph, but these are opposite. Okay. Now we have something that looks a little bit different, kind of like that word problem with the zombies. So on the left side, so this is the left side, okay? On the left side, as x is going to negative infinity, f of x is kind of stopping here in the middle. So in the middle, that would be 0, okay? On the right side, as x is going to positive infinity, so over here, so right here, well, the graph is going up. So f of x is going to positive infinity, okay? And that's it. That's just regular end behavior, okay? So number 12 says, do any of these have anything in common? So, and that should be, this right here should be different numbers. It should be 9 through 11, okay? Again, your paper is probably correct, but I have the original copy, so just make sure you're doing the right problem, okay? So from these three, do any of these have in common? Well, I can see that these two have nothing in common. So these two have nothing in common, okay? These two, let me see. Nope, nothing in common either. So let's hope it's this part. So let me see. Yeah, so both of these ones, so the first graph and the second graph, I'm sorry, the third graph, these are the same. They have the same right in behavior. Okay, just gonna leave it like that. So right here, I'm gonna say that number 9 and number 11 have the same right and behavior. Okay, and it says describe this using correct notation. So we already have the notation. We have that as x approaches positive infinity. I'm just copying this part right here, this part, and this part. Okay, f of x is also going to positive infinity. That's it. Okay, so we're just, a little bit of in behavior, then comparing and contrasting. Let's move on to the next one. So I believe this is number 14 in your paper. This one is asking you to fill in all this stuff right here. Okay, so it's kind of a lot of things. I went ahead and added the graph here. Again, I used Desmos to graph this. And I just zoomed in on the middle part because here is where it shows me the zeros. I have 1, 2, 3 zeros. Okay, so just keep that in mind. Okay, so my zeros, that's where it crosses the x-axis. We have x equals -5. So that's this one. Okay, x equals, let's see, 1, 2, -2, and x equals 1. Okay, so we have 3. Okay, now there's this question that says, are there any double roots? So I'm not sure if we talked about this in class, but I do know you saw it in Algebra 2. A double root is pretty much when one of these, so one of these, has a 2 up here. Okay, so yes, at x equals -5. And if you look at it, this point right here, it's just the very tip of it that touches the axis. So anytime this happens, this is called a double root, okay? Complex roots, we have not even seen, so don't even worry about that. None. You can cross it out if you want, okay? Number of turning points. Okay, so this part right here, you might have to, well, if you have the graph, you can see how many there are. But this is how many little hoops we have, like this, okay? So we're going to see how many we have. I can tell by looking that there's one right here. So one, there's probably one up there. So we have 1, 2, probably one down here, 3. So the number of turning points should be 3. Okay, now let's check. Okay, so up here, the degree for this should be 4. The reason I know it's 4 is because I have 1, 2, and then this one is 2 more. So 1 plus 1 plus 2 is 4. So the degree should be 4 for this. And the number of turning points is usually n minus 1. Again, this is in your notes. So that would be 4 minus 1, which is just 3. Okay? And again, if this part confused you a little bit, just look at the graph. Okay, so you can also just look at the graph. Okay? And count. There's really no reason to fail this test. A lot of it is stuff you can just kind of look at. Okay? Decreasing between, so this part right here is asking where the graph is going downward. For this part, you will definitely have to look at the graph. So I'm going to go ahead and leave it blank. I'll let you guys do this in class if you have questions about these. So let me see, these ones right here. Okay, you can ask me about them in class. Just because it's a lot easier if I have a calculator to show you with that part. Okay. And finally, the domain and the range. So the domain for this, if you look at the graph, it goes forever to the left, forever to the right. So it's going to be from -infinity all the way to infinity. Okay? The range depends on that lowest point. So this one again we'll do in class. Okay, because I just don't have the access right now to the calculator stuff. Okay. All right, let's go ahead and move on. We have composition, and we're at about 20 minutes, so I think we could maybe do a few more. Okay, so let's go ahead and look at this one. It says, given the following functions, find the compositions below. So it's been a while since we've done composition, I'd say about a week or so. So you might want to pay attention here, okay? So the first one is f of g of x. So this means we're going to take g of x, which is this one, okay, and plug it into f. So f of g of x is equal to, well, f is just right here. This is f, which is all this, x minus 5. So instead of x, I'm going to put a big old parentheses, because what I'm trying to do is substitute this piece into that x. So all this is going to go inside there, okay? And then we just simplify, so that's x plus 5 minus 5. These are going to cross out, so it's just equal to x, okay? We're going to do the same thing over here now. So now I have that f of x is getting plugged into g, okay? So we're going to start with g of f of x, and g is equal to all this. So we're going to have a big old parenthesis. So this x right here is the parentheses, okay? And plus 5 at the end. And inside here, we're going to plug in, well, we're going to plug in f of x. So f of x goes in here, which is this right here. So x minus 5, okay? And that's just going to be equal to x minus 5 plus 5. Those equal 0. So therefore, this is equal to x, okay? So you should be seeing something right now between these two. Just keep that in mind, okay? This is important. Let's look at the other two. So now I have j of x going into h. So j of x is all this, x squared plus 5. And h is this right here, okay? So h of j of x. We're going to copy all this. So the square root, okay? But instead of x, instead of this, we're going to put all that in there. So parentheses and then minus 5. Again, we're just substituting all this into that little x right there. So x squared plus 5 goes on the inside. Okay, and that's going to leave me with the square root of x squared plus 5 minus 5. So those are gone, which is the square root of x squared. But this cancels with the little x, with the 2, I'm sorry. So we're just left with x. Okay? And now we look at the opposite. So j of h of x. So h of x is going to get plugged into here now. So let's do that. So j of x is, let's see, j of h of x. J of x is equal to something squared plus 5. So again, all this little x right here is, this is the parentheses, okay? And we're going to take all this one and put it in there. So it's going to be the square root of x minus 5. So in this case, this is kind of nice because this and this cross each other out. So I'm just left with x minus 5 plus 5. But then these cross out, so that just leaves me with x. Oh, and I meant to change colors and I didn't. Sorry about that. Okay, that's it. So you should also notice something between here and here. Okay, let's do one more and then I'll go ahead and let you do the rest. So let's look at this last one. We have f, let's see, I use this one. So f, and we have h of x going in there. So h of x going in here. Okay, so f of h of x is equal to all this. So blank minus 5. And then this is supposed to go in here. So that's going to be this one. Okay, square root of x minus 5. Now here you can't cancel anything out because there's no square or anything. So we have the square root of x minus 5 minus 5. And that's about it. That's all you can do with this one. So this one, this is your answer. The square root of x minus 5 and then minus 5. So this one has no relationship. So there is no relationship here at all. Okay? Whereas for these two, there is. So there's something going on here and there's something going on over here. Okay? All right, so you can go ahead and do the rest of them by yourself. And I really want to focus on number 24 because 24 is actually kind of important. Okay, so it says which functions represent a commutative relationship with each other. And then this one says are inverses of each other. So remember that for something to be an inverse with composition, f of g of x should equal x, and g of f of x should also equal x. And it turns out that these two things are equal. So commutative means that it kind of goes, it's equal to, it's the same both ways, okay? So you get the same answer both ways. Because here we have f first and here we have g first. But they're both equal to x. So in this problem, the ones that would be commutative would be f of x and g of x. So f of x and g of x are commutative. Okay. So these two and these two. So h of x, that's an h, okay? And j of x are commutative. And another way to check them is just to see if they're inverses. Remember that if these equal to x, they're inverses of each other. So since they are inverses of each other, this is the reason why they're commutative. Okay? I think I'm going to stop right there. We'll go ahead and do the rest of the problems in another video. That way this one is not too long. Okay? Thanks for watching.